Okay, so we're starting this paper February-March 2020, paper 3-2. Let's take a look at question number 1, which says, sketch the graph of y equals modulus of x minus 2, which means we will be sliding our V-shaped graph 2 units to the right. So you need to make a proper x-axis, a y-axis, label it x and y. X-axis, y-axis, and we're going to mark 2 on the x-axis because this shape is going to slide 2 units to the right. Now we're going to make a V-shaped graph on it. It has to be as symmetrical as possible. So if it's like this on one side, it's going to be symmetrical on the other side. Something like this. And you must mark the y-intercept as well. How will you find the y-intercept? By making x 0. So y equals modulus of 0 minus 2, which is just modulus of minus 2, which is y equals 2. So we'll mark a 2 over here. So the examiner needs to see a 2 on the x-intercept, a 2 on the y-intercept. Okay. Moving on to the second part, solve this inequality. Modulus of x minus 2 is less than 3x minus 4. Okay, let's start. What we'll do, we'll remove this modulus on the left-hand side and write plus minus instead. So plus minus modulus of, brackets, modulus is gone. Now we have brackets. And we're going to solve both of these inequalities, once with a positive sign and once with a negative sign. So we'll do x minus 2 less than 3x minus 4. Let's solve this one first. We'll have 2x on one side, 2 on the other side, and then we have x is greater than 1, which I'll rewrite as x greater than 1, because conventionally you're supposed to have the variable on the left hand side. So x is greater than 1. Okay. Now let's deal with the negative sign. So negative x plus 2 less than 3x minus 4. Rearrange, we'll have 6 less than 4x. And then a 3 over 2 less than x. Rearrange, x greater than 3 over 2. Now we have a problem. We have both greater than signs in both the answers. X is greater than 1 and x is greater than 1.5. That can't be right. One of these is right, one of these is not. Only one of this is going to be our final answer. The other one has to be rejected. Now, how do we know which one to reject? Its best approach is to plot this straight line on the same graph. This is a straight line, y equals 3x minus 4. We're going to make a dotted figure here on the solution space for part A. Okay, this means the y-intercept is negative 4. So that means this would be negative 2 and roughly this would be negative 4. So y-intercept is negative 4 and then gradient is positive. So it's going to be a rising line upwards. And let's also find the x-intercept. Let's make y 0. So then we get 4 upon 3, which is 1 point something, 1 whole 1 over 3. So that's going to be, if this is 1, 1.5 would be somewhere over here. So you make a dotted line passing through these 2 points. So we see that we have an intersection somewhere between 1.5 and 2. So, which it's between 1.5 and 2, which means this one has to be the correct answer. X is greater than 1.5. The other one has to be rejected. So you must write only with this solution. Saad, any questions so far?
No, ma'am.
Okay, let's move on to question number 2, which is a question on log. So solve the equation, give your answer in simplified exact form. Okay, so what we'll do, we will try to get rid of ln, but for that we need a single ln term here, a single ln term here, so that we can cancel ln on both sides. So since the log terms are multiplying here, so what we'll do, we'll rewrite it as ln, and now we're going to multiply the arguments 3 times, 2x plus 5 equals to, on this side, this 2 is bothering us. What we'll do, we'll send it to the power so that we have ln here as well. So this is what we get on both sides after applying log properties. Now you can cancel ln on both sides, excuse me, and write 6x plus 15 equals x plus 2 whole squared. We've cancelled log on both sides. Now this is a quadratic equation. We need to expand the left hand side. So 6x plus 15 equals x squared plus 4x plus 4. 0 equals x squared minus 2x minus 11. Now we'll have to use the quadratic formula. So x equals minus b plus minus b squared minus 4ac upon 2a. Enter this in your calculator and you'll get x equals 1 plus 2 square root of 3 and x equals 1 minus 2 square root of 3. Now, since this is a question on log, it's highly likely one of these answers would not be accepted. Let me check this one. Is this a negative value? 1 minus 2 square root of 3. Yes, it is a negative value. It gives us x equals negative 2.4. And we can't have negative value here because then that would make this term negative. If we write ln, we got negative 2.4 plus 2. So we're getting a negative argument inside log, which gives us a math error in the calculator, which means it's undefined. So you can't substitute a negative input in the log function. That's why this second solution has to be ignored, and our only answer is this. So you highlight it and write only. And with this, you may write no solution. Saad, you're expected to stop me and let me know wherever you have confusions. Now we start question 3.
Hello, जी ma'am.
I was saying that you're supposed to stop me and tell me wherever you have problems, okay?
ओके मैं बताऊंगा.
Okay. Question 3. By sketching a suitable pair of graphs, show that secant x equals 2 minus half x has exactly one root within the interval 0 to half pi. Okay, so you need to first sketch the graph for secant x. So a y-axis, an x-axis properly labeled x, y. Okay. Secant x is the reciprocal for cos x. So let me roughly sketch the graph for cos x first. This is what cos x looks like. This is one full period which goes from 0 to 2 pi. That means this is pi and this would be half pi. So we're only interested in this part because the domain is 0 to half pi. Okay. Now we know that secant x is the reciprocal for cos x. So let me make cos x in the given domain slightly wider. So cos x looks like this. It's 1 here and 0 here at half pi. Okay, so if we're sketching the reciprocal of this graph, we know reciprocal of 1 is still 1. So we'll have a point starting from 1. When cos x is 0 here at half pi, secant x will be undefined because the reciprocal of 0 is undefined. So we make a dotted line here which shows the asymptote and write pi by 2 here, and your graph will go like this. Do not let it touch the asymptote. It will get very close to it, but it won't touch it. Let's make the y-axis slightly longer as well. So that's the graph for secant x within the domain 0 to half pi. Okay. Now we have to sketch the other graph, which is this part, y equals 2 minus half x. That's a linear line. Its y-intercept is 2. So I'm going to mark 2 over here, and it's going to be some falling line. Okay. How quickly will it fall or how gradually will it fall? I'll try to find another point on this line. I have pi by 2 on my graph. So let me try to find the value of y when x is pi by 2. So y would be 2 minus half pi by 2. What is that? So 2 minus pi by 4, that gives us 1.214. Okay, so it's going to be slightly higher than 1, somewhere over here. So now I'm going to make a straight line passing through these 2 points. So that's the second graph for y equals 2 minus half x. Label these graphs properly. This is y equals 2 minus half x, and this is y equals secant x. Now we can see there's only one point of intersection. So we write our concluding statement that one point of intersection shows one root. Make sure you make a tiny x on the point of intersection. Okay. Next part, verify by calculation that this root lies between 0.8 and 1. What we'll do now is move both parts of the equation to the same side and write fx equals secant x is 1 over cos x. Bring 2 to the other side, negative 2. Bring negative half x to the other side, plus half x. And you may write equals to 0 over here. Now we'll substitute 0.8 here and we'll substitute 1 here. And we'll show that there's a change of sign. So substitute f 0.8 we'll have 1 over cos 0.8 minus 2 plus half 0.8, and we get minus 0.1646. And then we substitute 1 here. So 1 over cos 1 minus 2 plus half times 1, that gives us 0.3508. Now you'll write a concluding statement that change of, in fact, write less than 0 with this one and greater than 0 with this one. And then write the concluding statement. Just give me a second. Okay, now we must write the concluding statement that change in sign shows that root lies between 0.8 and 1. Let me mention that here. Change in sign shows root lies between 0.8 and 1. Okay. Use this iterative formula to determine the root correct to two decimal places. Okay, we can start with x1 equals to 0.8 since it's given here. Now, for x2, show at least once full substitution. So cos inverse 2 upon 4 minus x is 0.8. Now in the answer key, save 0.8 in your calculator and do cos inverse 2 upon 4 minus answer, and you will get 0.8957. We have to show the result of each iteration correct to 4 decimal places. Now you can just keep pressing the equals to key in the calculator. It'll get us x3 equals 0.8707. Another equals to, we'll get 0.8756. No, sorry, 8774. Next will be 0.8756. Next will be 0.8761. Next will be 0.8760. Next is 0.8760 again. So we can see that the answer has converged correct to two decimal places. So you can write x equals 0.88 as the final answer, since we need the final answer in two decimal places. Okay, next question. Find the integration of x secant square x. Give your answer in simplified exact form. Okay, this is integration by parts, so we have to apply LIATE. Okay, we do not have log here, we do not have inverse here, but we do have algebra here, which is x, so we can say u is equals to x. That means dv by dx will be secant square x. Now we derivate u, which gives us a 1, and we integrate secant square x, which gives us a tan. Now let's apply the integration by parts formula, which is integration of u dv over dx equals uv minus integration of du over dx times v. Substitute the values. U was x, v is tan x, minus sign integration of du by dx is 1, and v is tan x dx. Okay, now let's quickly recall how do we integrate tan x. It cannot be integrated directly. However, we can write it as sin x over cos x. Now there's a rule in integration in which if you have a function in the denominator and its derivative in the numerator, so then it becomes ln fx. So when you integrate this, you get ln fx. Now we have a function in the denominator, which is cos x, but the derivative of cos x is negative sin x. So we need a negative in the numerator. So you can write a negative sign here and a negative sign here to balance it out, to cancel it out. So we get negative ln cos x. That's the derivative of that's the integration of tan x. So I'm going to rewrite this as x tan x. So we have x tan x, then a negative sign, then another negative sign, minus ln cos x, which becomes x tan x plus ln cos x. Integration is done. Now we substitute the limits, which were pi by 6 and pi by 3. Substitute these. You need to show the substitution. Pi by 3 tan pi by 3 plus ln cos, this is cos, pi by 3 brackets, a negative sign, pi by 6 tan pi by 6 plus ln cos pi by 6 which gives us pi by 3 under root 3 plus ln half minus bracket pi by 6 under root 3 over 3 plus ln under root 3 over 2. Okay, this can be further simplified. We can write the pi terms together. Just add these up in your calculator. In fact, subtract these in your calculator. These two. And we will get 5 under root 3 upon 18. Pi. And for these two, they're being subtracted. So we can take log common and divide them. Let me do these here. So ln half divided by under root 3 over 2. So this 2 and 2 cancels out. So we have ln 1 over 3 under root, and under root 3 is actually 3 power negative half. So ln 3 power negative half, which can be written as negative half ln 3. So I'll write negative half ln 3. This is the final answer. Okay, moving on. Show that cos 3x over sin x plus sin 3x over cos x is equals to 2 cot 2x. Okay, First of all, we'll write cos 3x as cos bracket 2x plus x. Now we'll apply compound angle identity for cos, which is cos 2x cos x minus sine 2x cos x. Sorry, sine x. We'll do the same for sine 3x. Rewrite it as sine 2x plus x, which gives us sine 2x cos x plus cos 2x sine x. Okay. Now we will substitute these values sine 3x and cos 3x in this equation and simultaneously take LCM. So in the denominator, we'll have sine x cos x. In the numerator, I'm writing sine 3x, which is this, but multiply cos x with it because we've also taken the LCM. Okay. In fact, let me do that in two steps. So cos x cos 3x plus sine x sine 3x. Now we replace cos 3x with this and sine 3x with this. So cos x cos 2x cos x. In fact, let me open the bracket simultaneously, otherwise it'll take too long. So we have cos square x cos 2x plus minus sine 2x sine x cos x plus, now we're going to multiply sine x with sine 3x. So this is sine 3x, multiply sine x with it. So we have plus sine x sine 2x cos x plus cos 2x sine square x. This and this conveniently gets cancelled out. And in the denominator, we have sine x and cos x. Okay, in the numerator, I'm going to take cos 2x common. So then in the bracket, we have cos square x plus sine square x left, which is just 1. And the denominator is sine x cos x still. Okay, now this pretty much simplifies to cos 2x upon sine x cos x. Now we need cot 2x. Cot 2x is cos 2x upon sine 2x. So how do we change the denominator to sine 2x? By just multiplying a 2 with it. And when you do that in the denominator, you'll also have to do that in the numerator. So we get 2 cos 2x upon sine 2x, which simplifies to 2 cot 2x, which was what we needed to show. Okay, hence solve this equation. So we rewrite the left hand side as 2 cot 2x. Equals to 4, which gives us cot 2x equals to 2, which gives us tan 2x equals to 1 over 2, because cot is the reciprocal of tan function. Okay, now the domain is from 0 to pi. Okay, we're going to substitute this with another variable. Let y equals 2x, which means x equals y over 2, which means we get y over 2 here in between the inequality, which means the new domain is now from 0 to 2 pi. So we have tan y equals to half for the domain 0 to 2 pi. Okay, let's find the absolute angle, tan inverse of 1. And since tan is positive, we plot it in the first quadrant and in the third quadrant. So shift tan 1 would be 0.4636. Make sure your calculator is set in radians. Okay, so one of my answers is coming out to be 0.4636 and the other answer is coming out to be pi plus 0.4636. This is one of the solutions and this is the other. So we get 3.6052. Okay, but we need the values of x and we know x is y upon 2. So divide both these answers with 2 and we get 0.2318 and we get 1.8026 and we need to give our answer in 3 significant figures. Yeah. So x equals 0.232 and x equals 1.80. Okay, next. Variable x and y satisfy the differential equation dy by dx equals 1 plus 4y squared upon ex. It is given that y is 0 when x is 1. Solve the differential equation, obtain an expression for y in terms of x. Okay, first thing we do is separate y's and x. So on the left side we have dy, bring the y terms here. So we'll have 1 upon 1 plus 4y squared equals to 1 upon ex dx. Okay, so now we need to integrate 1 upon 1 plus 4y squared dy equals to e minus x dx. Okay, the right hand side just becomes negative e minus x and then we'll have to add a plus c on one of the sides. I'm adding it towards the right hand side. Why did we get this? Because if you integrate e power fx, it stays e power fx divided by f prime x. So f prime x in this case would be negative 1. So we get e power minus x upon negative 1, which is negative e power negative x. Okay, now we need to simplify the left hand side. Okay, let me quickly open the MF19 document. Okay, here it is. Let's look at integration of this term. Okay, so we have this. So if we have to integrate 1 upon x square plus a square, it's equals to 1 over a tan inverse x over a. So we can rewrite this as 1 upon 1 squared plus, this is actually 2y whole square dy. Now integration of this is tan inverse 2y and with it we'll also get half. So half tan inverse 2y. Where did we get this half from? Because the derivative of 2y is 2 and it goes in the denominator. let me rewrite this function. So if you have 1 plus x square dx, it integrates to tan inverse x. But if instead you have a function here, like we do in this case, we did not have just y, we had 2y. So in that case, it becomes tan inverse fx and divided by f prime x, the derivative of 2y. So derivative of 2y is just 2, so that's why we divided it with 2 or multiplied it with half. So that's where this half comes from. Okay, so now I'm going to rewrite it as half tan inverse 2y equals to minus ex minus e power minus x plus c. Okay, now we need to find the value of, we know x is 1 and y is 0. So tan inverse 0 will just be 0. So we have a 0 here equals negative e to the power 0, which is negative 1. No, I'm sorry, x is 1. So we get minus e power minus 1 plus c, which means c is equals to e power negative 1 over or 1 over e. So we rewrite this as half tan inverse 2y equals minus e power minus x plus e power negative 1. Do we need to make something the subject? Solve the differential equation obtaining an expression for y in terms of x. Okay, so we need to make y the subject. So I'm going to send 2 to the other side. So we get negative 2 e power negative x plus 2 times e power negative 1. Then we'll send tan to the other side and we'll get tan of this entire thing. And then you can send 2 to the other side and you'll write divided by 2 or multiplied with half. This would be the answer. Y equals half tan minus 2 e power minus x plus 2 e power minus 1. Okay, next question. State what happens to y as x tends to infinity. Okay, so we have y equals half tan negative 2 e power negative x plus 2 e power negative 1. Okay, now they're saying x tends to infinity. Okay, so when x is becomes very large, that affects this. So we have negative 2 upon, let me just take e power negative x to the denominator so that it becomes positive. This becomes negative 2 upon a very large value. The denominator is very large, so that means minus 2 upon a very large value is almost 0. So we get y equals half tan, this becomes 0. So we have 2 power e negative 1. So you write y approaches half tan 2 upon e or 2e to the power negative 1. So when x tends to infinity, y tends to, y equals half tan 2 to the power e negative 1. 2e to the power negative 1. All right, question 7. The equation of a curve is x cubed plus 3xy square minus y cubed equals to 5. Show that dy by dx is equals to that. Okay, this is a question on differential equation. Let's solve this. So differentiate x cube, we get 3x squared plus, write 3 outside of the bracket, and now we'll apply product rule of differentiation on this. Derivative of x is just 1, so we write 1 times y squared, a plus sign. Derivative of y square would be 2y dy by dx. So first write x as it is, then we write 2y, and since it's y, you have to write dy by dx next to it, bracket close, minus integrate y cube, so 3y squared and dy by dx equals to, derivative of 5 is just 0. Okay. Expand 3x squared plus 3y squared plus 6xy dy by dx minus 3y squared dy by dx equals 0. I'm moving the dy by dx terms to the other side, so 3x squared plus 3y squared equals, both terms go to the right hand side and take dy by dx common, so we get 3y squared minus 6xy. Okay, now we can take 3 common. In fact, divide this here. So also take 3 common both in the numerator and denominator. So 3 common, x squared plus y squared in the numerator. In the denominator, 3 common, y squared minus 2xy equals to dy by dx. And when these cancel out, we get the required form, x squared plus y squared over y squared minus 2x1. So that's also done. Okay, next part. Find the coordinates of the points on the curve where the tangent is parallel to the y-axis. Okay, let me make a curve with the tangent parallel to the y-axis, which means dy by dx is infinity, which means undefined. Dy by dx would be undefined, which means denominator is going to be equals to 0. So we have to equate this denominator to 0. That's how we start the question. So y squared minus 2xy should be equals to 0. Factorize y bracket y minus 2x equals to 0. So we're getting either y is equals to 0 or y is equals to 2x. Now we have to find the corresponding values of x and y. So when y is 0, substitute it in the original curve here. So we'll have x cube equals 5. So x equals cube root of 5. So we get x equals cube root of 5. So one of the coordinates is cube root of 5. Cube root should look like cube root. It shouldn't look like 3 times square root of 5. So let me rewrite this, cube root of 5. Okay, comma 0. This is one of the coordinate. For the second one, replace the y in the original equation with 2x. So we get x cubed plus 3x. Y gets replaced with 2x and there was a square on it. Minus, then there was a cube on y. So 2x whole cube equals to 5. Okay, this gives us x cubed plus 12x cubed minus 8x cubed equals to 5, which gives us 5x cubed. Yeah, 5x cubed equals to 5, which gives us x cubed equals to 1, which is x equals 1, which means y equals to 2. So 1 comma 2 is the other coordinate. These are the two answers. Okay, Assalamu alaikum Saad. We're continuing with question number 8.
Okay, ma'am. Walaikum assalam.
In the diagram, OABCDEFG is a cuboid in which OA is 2 units, OC is 3 units and OD is 2 units. Unit vector ijk are parallel to OA, OC, and OD respectively. The point M on AB is such that MB is equals to 2 times AM. The point FG is N. The point of the midpoint of FG is N. Express OM and MN in terms of I, J, and K. Okay. All right. So if OA is 2 units, that means the vector OA is 2I. If OC is 3 units, that means this vector OC is going to be 3J. And since that's parallel to OC, that's also going to be 3J. So this full vector is going to be 3J. However, we're told that MB is equals to 2 times AM. So MB, if we rearrange it, if we cross multiply, so we have MB over AM is equals to 2 by 1. That means if MB has 2 parts, AM has 1 part. So we'll have 2 parts here and 1 part here. So this will be 2J and this will be J. And then we're told that OD is 2 units. That means this vector upwards is going to be 2K. Okay. Now we need to go from O to M, which means we need to find this vector OM. So that's just 2I plus J. So OM is 2I plus J. Okay. Next is vector MN. Okay. So we have to go from M to N. We can also do ON minus OM by using the position vectors. MN is ON minus OM. Okay, let's go from O to N. Okay, so I'm going to go up first, 2K. So let me write that down. ON is going to be 2K. Then we can go in this direction, which is 3J. So plus 3J. And then we can go, in this direction, which is N is the midpoint of GF. And this direction is 2I, we know from here. So it's going to be plus I only. So plus I. Okay. Similarly, we need OM, which we found already, which is 2I plus J. So let's just subtract these. So from this, I'm going to subtract OM, which is 2I plus J. That will give us MN. Let me write M here. Okay, so MN will be, remember we have to write I first, then J, then K conventionally. So we have minus I plus 2J plus 2K. So this is the position vector, this is the vector MN. Minus I plus 2J plus 2K. Okay. Next is part B. Find a vector equation for the line passing through Mn. Okay, that means we're going to write R is equals to, the formula is R is equals to A plus lambda B minus A, where A is one of these position vectors. Either take position vectors of M or take position vector of N. I'm taking M. So R is equals to, I'm writing OM plus lambda. B is the position vector of the other point, which is N. So ON minus OM. We've already found ON minus OM in part A. That came out to be minus I plus 2j plus 2k. So plus lambda minus I plus 2j plus 2k, and OM is this 2I plus j. So R equals 2I plus j plus lambda minus I plus 2j plus 2k. That's the answer for part B. If you have any questions, please ask me in between. Okay. Moving on to the next part. Find the position vector of P, the foot of perpendicular from D to the line through MN. Okay. So we have to draw a perpendicular from D towards the line MN. Okay. Here's D. There's D. Here's MN. Going to draw a perpendicular and name this point of intersection P. And now we have to find position vector of P. So we have to find OP. Let me draw this again here. So we have D, then the vector MN, and then a foot of perpendicular P. Okay, now we already have vector equation for the line MN. We already have its vector equation. What is that? R is equals to, let me write it as a column vector this time. I, j, k, so 2I plus j, which is 1, and k is 0, plus lambda, and we had minus I plus 2j plus 2k, so I'm writing it like this, minus 1, 2, and 2. This is the vector equation or vector equation Mn. Okay, now since P lies on this line, position vector of P will be 2 minus lambda, 1 plus 2 lambda, and then 0 plus 2 lambda. We need to find the value of lambda, substitute it here to get the proper position vector of P. Okay. We also know the position vector OD from the figure. Let's take a look. Okay, OD is just 2k. So we'll write 0, 0, 2 for OD. So OD is 0, 0, 2. Okay. Next thing we do is find this vector dp. dp is going to be OP minus OD. We've already written both these position vectors. Let's subtract them. 2 minus lambda, 1 plus 2 lambda, 2 lambda, minus 0, 0, 2. Which gives us 2 minus lambda, 1 plus 2 lambda, and 2 lambda minus 2. That's the vector PD. Okay. Now we know that vector, there's a 90-degree line, there's a 90-degree angle between DP and MN, meaning they are perpendicular. So the dot product needs to be 0. Now dot product of what needs to be 0? We already have this vector DP. So dp dot something is equals to 0. What is that something? We need a vector in this direction, which we already have. We have mn. Remember, we found the vector mn while we were finding the vector equation passing through mn. So this is actually a vector. This is called direction vector. So it's a vector parallel to the line mn. So we're going to find the dot product of dp and this direction vector and equate it to 0. And from that, we're going to find lambda. So dot product of dp, which is this, and the position vector of mn, sorry, the direction vector of mn, which is minus 1, 2, and 2, and equate it to 0. Okay, now let's expand this. Minus 2 plus lambda plus 2 plus 4 lambda plus 4 lambda minus 4 is equals to 0. We're getting 9 lambda here and minus 4 on the other side. So lambda is equals to 4 over 9. Now we can find OP by substituting 4 over 9 here in the position vector of OP in terms of lambda. So replace lambda with 4 over 9. So 2 minus lambda would be 14 by 9. 1 plus 2 lambda will be 17 by 9. Excuse me. And 2 lambda is going to be 8 by 9. However, please remember to write your final answer in the form of I, J, K, because this entire question was in the form of I, J, and K. So we're going to write 14 by 9 I plus 17 by 9 J plus 8 by 9 K. That's question 8. If you have any questions, please ask me. Okay. Then we move on to question 9. Let me just write the entire fraction. 2 plus 11x minus 10x squared upon 1 plus 2x, 1 minus 2x, 2 plus x. In fact, the first thing you should be doing is checking whether there's a need to do long division, whether it's that case. But it's not in this case because we have x square in the numerator, and if we expand, we'll have x cube in the denominator. If these degrees are equal, like if the numerator was also x cube, or if the degree of numerator is bigger, then there's a need to do long division. this is not that case. This is the simple case where we'll equate this to a over 1 plus 2x plus b over 1 minus 2x plus c over 2 plus x. Now we're going to take LCM on the right hand side and then cancel both the denominators on both sides. So 2 plus 11x minus 10x squared equals, we'll take LCM and multiply the other two denominators with a, the other two denominators with b, and the other two denominators with c. Okay. Now I'm going to start with let x equals, if I want to equate this to 0, if I want to make this 0, I'll have to write 1 minus 2x is equals to 0, which means x equals half. So I'll start with let x equals half, so that 1 minus 2x becomes 0 and we get the value of b. Okay. So let 1 minus 2x is equals to 0, or let x equals half. Okay, now substitute that here and this will become 0, this will become 0, and substitute that here. So that would give you 5 equals to 5b, which gives us b equals 1. Okay. Next, I'm going to equate this to 0, so that this terms become 0 and this also becomes 0, and we'll be able to find the value of c. So I'm going to write let x is equals to negative 2. That will give us negative 60 on the left hand side and negative 15c on the right hand side, which gives c equals 4. Next, which bracket is now to be equated to 0? This one, 1 plus 2x. So when we equate this to 0, we get minus 1 is equals to 2x and x equals to negative half. So x equals negative half. Equated on the left hand side, we'll get negative 6. Now a term will become 0, c term will, b term will also become 0. Sorry, c term and b term will become 0. This will become 0 and this will become 0. And we will be able to find the value of a. So the coefficient of a would be 3a, which gives us a equals negative 2. So now we express it completely in partial fractions. Minus 2 over 1 plus 2x plus 1 over 1 minus 2x plus 4 over 2 plus x. So we're done with partial fraction part A. Okay, next part. Hence obtain the expansion of fx in increasing power of x up to and including x squared. Okay, so I'm going to rewrite the partial fractions, but I'll move the denominators up and make their powers negative. So we'll have 1 plus 2x powered negative 1 here. Then we have 1 minus 2x power negative 1. And then we have plus 4, 2 plus x power negative 1. Okay. Now this can be directly expanded because the first term is 1. This can be directly expanded for the same reason. This can't be expanded unless you get rid of this 2 and change it into 1 by taking 2 common. Let's start with that. So we're going to take 2 common, but when you do that, you'll get the power with it as well. So it'll be 2 power negative 1. When you take 2 out of this bracket, it will come with its power. So 2 power negative 1. Okay, here we'll have 1 and here we'll have x over 2 and power negative 1. So now we have 4 over 2, which is just 2. 2, 1 plus x over 2 power negative 1. Okay, let's rewrite all of them. Okay, now we're ready to expand all of them using the formula 1 plus x power n. This is 1 power n plus nx. How many terms we have to find? Okay, we just have to go till x squared. So nx plus n minus 1 over 2 factorial and x squared. Okay, let's apply that. So I'm starting with 1 plus 2x power minus 1. So first term will be 1 power negative 1, which is just 1. Then plus n times x. This plus n minus 1 over 2 factorial times x squared. This. Okay, we'll simplify this. And we'll get 1 minus 2x plus 4x squared. So we have expanded this. Okay, now let's expand this. So 1 minus 2x power negative 1. Which will be 1 power negative 1, which is just 1, plus n x plus n minus 1 over 2 factorial times x squared, which will give us 1 plus 2x and plus 4x squared. And then lastly, we're going to expand this. Which is 1 plus x over 2 power negative 1. Okay, this will be 1 power negative 1, which is just 1, minus nx, plus nx actually, plus nx, plus n minus 1 over 2 factorial x over 2 whole squared. This gives us 1 minus x over 2 1 minus x over 2 and plus x squared over 4. Now we rewrite them with their coefficients or whatever was multiplying with them outside of the bracket. So we had minus 2 multiplying with all of this. So 1 minus 2x plus 4x squared. Then we had plus 1 multiplying with this. So we just write plus 1 plus 2x plus 4x squared. And then we had 2 multiplying with this. So we'll write plus 2, 1 minus x over 2 plus x squared over 4. Okay, now let's completely expand it and then simplify. We get minus 2 plus 4x minus 8x squared plus 1 plus 2x plus 4x squared. Now we double everything in the last bracket. 2 minus x plus x squared over 2. Add the like terms, add all the constant, minus 2, 1 plus 2, so that's just a 1. Add all the x terms, so we have 4x, 2x, minus x, that's going to be plus 5x. And then add all the x squared terms, negative 8x squared plus 4x squared plus half x squared, so that's going to be minus 7 over 2 x squared. And the expansion is done. Okay. The complex number v and w satisfy this equation. Solve the equation for v and w. Give your answer in the form of x plus iota y, where x and y are real. Okay, so we have v plus iota w is equals to 5. So that means v is equals to 5 minus iota w. We're going to substitute that in the second equation, which is 1 plus 2i. V gets replaced with 5 minus iota w minus w is equals to 3i. Expand the brackets. 5 minus iota w plus 10 iota minus 2w iota squared minus w is equals to 3i, and we know iota squared is negative 1. So we have 5 minus w iota plus 10 iota, then we'll have plus 2w minus w is equals to 3 iota. Okay, so now let's keep the w terms on one side. We'll have minus wi plus w is equals to move all the non-w terms to the other side. So 3i minus 10i would be minus 7i, and then we have a minus 5. W common, we'll have 1 minus iota is equals to minus 7 iota minus 5. Cross multiply, minus 5 minus 7 iota upon 1 minus iota. Now we rationalize. So we'll multiply and divide with the complex conjugate of the denominator, which is a 1 plus iota. Okay. Simplifying this will give us the value of w. So the denominator becomes a squared minus b squared. Numerator becomes minus 5 iota minus 7 iota, then minus 7 iota squared. So we have w equals minus 5 we have -7, 12 iota, then +7, because iota squared is -1, and denominator is a squared minus iota squared is -1. So we have a 2 in the denominator. So we have 2 minus 12 iota upon 2. Take 2 common in the numerator, cancel it with the denominator. So W is equals to 1 minus 6 iota. Next part, where we have to find the value of V. So now we're going to replace W with the expression that we got, 1 minus 6 iota. We already have found W, substitute it here and get the value of V. So 5 minus iota plus 6 iota squared. Okay, that gives us 5 minus iota minus 6. That gives us -1 minus iota as the value of V. So V is this -1 minus iota, and W is this 1 minus 6 iota. Okay, part B. On an Argand diagram, sketch the locus of points representing the complex number z satisfying modulus of z minus 2 minus 3 iota is equals to 1. Okay. So the left hand side is a circle with center 2 comma 3, and this gives the radius is 1. So we have to plot a circle which has a radius of 1 and a center at 2 comma 3. It is highly advised that you use construction tools here to make a proper circle. That way you're less likely to make a mistake. Although freehand sketches are also accepted, but it's better if you use construction tools. Okay, so 2 comma 3, so you will use a ruler and mark these properly. This is 1, this is 2, this is 3. Maybe you could use 1 centimeter is equals to 1 unit, 4, 5, and so on. Label this X, and then 1, 2, 3, 4, 5, and so on. Here's 3. So our center is right here at 2 comma 3. Now we need a circle which has a radius of 1 around this. So something like this. Yeah, radius 1 and center 2 comma 3. Okay, so something like this. Okay, so B1 is done. Part 2. Calculate the least value of argument of z for the points on the locus. Okay, argument of z means angle with the origin. So, what angle would be the smallest? Like, for example, if we make an angle passing through the circle from here, will this angle be the smallest? No, this angle won't be the smallest. This will keep getting smaller, 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 smaller. In fact, this angle would be the smallest value. So this is what we need to find. We need to find this angle. Now, how do we do that? We'll have to make use of trigonometry and circle properties. Okay, so this is the radius, right? This will have this is 1 unit. And we know from O levels that radius and tangent, they are perpendicular. So we have a 90-degree angle here. Okay. Then you're going to make a line connecting the origin to the center of the circle. This line. Okay. So we know the length of this line because we know that it connects 0, 0 with 2, 3. So we can apply distance formula on 0, 0 and 2, 3. So that will be, let me do the working here. So square root of 2 minus 0 whole squared plus 3 minus 0 whole squared. That's a 4 plus 9, which is going to be square root of 13. So this length is square root of 13. So we can find this angle. However, we need the angle under that. We need the angle which is marked in blue. How would we do that? We would then find this angle, this full angle. This can also be found because this length is 3 units. So, and this is a right angle as well. So there we have 3 and we also have under root 13 on the same triangle. So we're going to find this full angle and then subtract it from the red angle and get our desired value. Okay, so let's find the black angle first. Let me draw the triangle separately. So we have under root 13 here, 3 here, and this angle would be tan theta, no, sine theta. Sine theta is equals to opposite over hypotenuse. So theta is sine inverse 3 over under root 13. In fact, we also had this length. This was 2, so you could have used that as well. So you could have used any trigonometric ratios. Okay, now let's find the red one. That is, let me draw the triangle again. So we have a 1 and we have a square root of 13 and we need this angle. So this will use sine as well. Theta is equals to sine inverse 1 over under root 30. So now we're going to subtract both these angles. Sine inverse 3 over under root 13 minus sine inverse 1 over under root 13. I'm doing this together to avoid premature approximation. Make sure your calculator is in radians. So sine inverse 3 by under root 13 minus sine inverse 1 over under root 13 which gives us 0.70175 which gives us 0.702. We have to round off angles and radians to 3 significant figures, and the paper is completed. I think that was the last question. Yes. So if you have any questions from this paper, please ask.
No, ma'am.
Understood, ma'am.
Okay.
No, ma'am.
Okay. So just give me a second. Let me stop recording and then talk to you guys.